Okay, there we go. Okay, good evening, everyone. Thanks for coming. I'll just ask again for people that are just coming in that you mute your mics, and welcome. And we're very excited about tonight. It's being recorded if you're not able to, if you know someone that wasn't able to come. I'm Jocelyn O'Zolins from the Shelter Island Library. And first of all, I want to thank John W. Briggs for generously sharing his expertise with us. And thanks also to the Hamptons Observatory who arranged this, and Donna McCormick in particular. Just to give you some information about the observatory, their website is www.hamptonsobservatory.org, and their Gmail address is hamptonsobservatory@gmail.com. And just for the next event that they're having virtually, it will be The Benefits of Dark Skies to Long Island by Susan Harder on January 11th at 7 p.m. And now I can introduce tonight's speaker, John W. Briggs. He's lived and worked at far-ranging observatories in various technical capacities, including Mount Wilson, Yerkes, National Solar, Maria Mitchell, Venezuelan National, Chamberlain, and South Pole Station. He came to New Mexico with his family in '97 to assist in the final commissioning of the Sloan Digital Sky Survey at Apache Point. In the 1980s, he was an assistant editor at Sky and Telescope magazine and built Bogsucker Observatory in Massachusetts. He's a member of many astronomical organizations, including the Springfield Telescope Makers, who are responsible for the annual Stellophane Convention in Vermont. And he's recently been elected to the board of the century-old American Association of Variable Star Observers. His principal activity now involves the Astronomical Lyceum, an informal museum, library, laboratory, and lecture hall devoted to historical astronomy and its preservation, located in a 1936 former school gym theater in Magdalena, New Mexico. And thank you again, John, and I'll turn things over to you.
Great. Hey, thank you very much. Thank you, everybody, for being here. I think I'm going to press screen sharing, I guess. And there we go. Share. And let's see if I can make this work. And I'm going to, there. Do people see the observatory picture? I trust they do. But yeah, hey, in this era when so many of us are getting quite zoomed out, aren't we? Thank you very much for being here and for your attention. And so my plan tonight is to share with you an experience I had back in 1994, living an entire year at South Pole Station. The objectives there were scientific, and I will at least allude to the science that was going on at South Pole in '94. Things have grown there. Programs have expanded tremendously. And really my presentation has become historical because boy, doesn't the world turn. But I'm going to focus on the human interest of the experience that I hope you will all enjoy and appreciate, but I better get right into it because I have a lot of slides and the pictures speak for themselves often, but every picture inspires an anecdote, and if I don't watch out, I'll go on and on and on and on. But anyway, I was working for venerable century-old Yerkes Observatory of the University of Chicago, located in Wisconsin. And this is the mighty dome of Yerkes Observatory, like a cathedral of science. And it was headquarters of an organization that had been funded by National Science Foundation to explore the high Antarctic plateau for its potentially advantageous conditions for astronomical observations. Now, Yerkes Observatory is especially famous for the gigantic lens-type refracting telescope dedicated in 1897. This telescope with a tube 63 feet long to this day is the largest lens-type telescope in the world. Interestingly, about the time the mighty refracting telescope at Yerkes was built, astronomers were already beginning to shift to using mirrors for their main telescopes, and there are certain technical advantages of mirrors. But don't get me going on telescope details, because that's my forte, and I love to talk about telescope details the way some guys like to talk about Harley carburetors or whatever. But in any case, this was the organization, Center for Astrophysical Research in Antarctica, which was funded in a relatively long-term way by National Science Foundation, as I recall. The idea was to allow this project to run over a decade, to take its time, really building a foundation of new experience at the South Pole Station as an astronomical observatory. Well, let me tell you a little bit about what it was like. And I'm planning to take you there and back, the experience of a year in the coming slides. So let's begin. So to travel to South Pole Station, one flies by conventional airlines, typically to Christchurch, New Zealand. What a beautiful place New Zealand is to visit. Everything you say about it, hear about it, is true. In Christchurch, on the South Island of New Zealand, there's a facility called the International Antarctic Center. And ahead of time, you have sent them all of your measurements and everything they need to know to outfit you with the appropriate clothing for whatever your experience is going to be on the ice. And various countries take advantage of the logistical support of the International Antarctic Center in Christchurch, but the American program operating out of there with its support is especially strong. So then eventually you get a place on a military style transport aircraft, and that's what you're seeing here, a scientist looking out one of the windows of this LC-130. It's a turboprop aircraft, actually with skis, as you'll see, an unusual thing. And there aren't too many windows, and it's very different from a commercial flight. But one thing I will remember to mention is that it's a 7.5-hour flight from Christchurch to McMurdo Base on the coastline of Antarctica. Now, on the trip in, that was related to my winter over experience, I actually had to try 3 separate times. But on the first 2 times, something went wrong. There was either bad weather or some trouble with a radar system or something. Because the weather conditions are so unpredictable still in Antarctica, the ability to forecast is difficult. They have to be very, very conservative with things like long distance airplane flights. And so the first 2 times things were not looking perfect. So halfway to McMurdo Station, our big military style airplane turned around and we went home to, went back to New Zealand. Now I was told that sometimes groups trying to get in would attempt essentially a dozen times before finally they were able to get all the way to to McMurdo Base. But that just dramatizes how fundamental transportation and communication and such things cannot be taken for granted in Antarctica the way they can, relatively speaking, so many other places. So what does it look like when you get above the Antarctic continent? The first thing you pass over for a while before you get to McMurdo Base are some elements of the trans-Antarctic mountains. And oh my goodness, I shot a lot of pictures out the window looking down at glaciers like this. And you can see, I hope, that there are crevasses down there. Although some of those would be big enough to swallow a whole house or a big building. And of course, people travel to Antarctica in the science program for a very broad diversity of sciences. Our project was all about astronomy and astrophysics, but of course, glaciologists naturally go down there to study everything about glaciers like this. Well, I'm just going to keep going before showing too many pictures of glaciers. They were mind-boggling to me, but we have to get all the way into South Pole Station. So I will just show you that here is the aircraft landed safely at McMurdo Base. And that's actually me in younger and skinnier days. And you can see the interesting skis that have lowered below the wheels. That's what an LC-130 aircraft is, with a special ski modification. And there really are not too many of these aircraft in the existing in the world, as I understand. The ones that we were using were operated mainly by the New York State National Guard of all organizations. At least that's the way it was back in '94. And so, of course, when I got this picture back from the developer, this slide, I thought, boy, I look cool. I passed it to my engineer friend, and I showed it off to him, and obviously with some pride. And of course, he just said to me, well, Briggs, look, yeah, you look, everything's cool, but at least couldn't you have buttoned your shirt straight? Well, anyway, that's just the way it was. But let me just say that when you're traveling to South Pole, you may end up spending a good handful of days at McMurdo Base on the coast, which is the center of operations for all manner of US science. But in our case, our destination was South Pole Station. That was another 3.5-hour flight. And here is one of the aircraft landing at South Pole Station. The flags and the little monument there is what they referred to as the ceremonial South Pole. They had a large inventory of flags, so that if we had visitors and dignitaries from almost any country on Earth, it was possible to bring out the appropriate flag so that visitors like that could have their flag present for a photograph beside the ceremonial South Pole. But as I'll try to point out to you towards the end of the presentation, the actual geodetically measured South Pole, which has to be adjusted every year because all this ice here, all 9,300 feet thick of ice slab, is actually a gigantic glacier on the high Antarctic plateau. The ice is moving. So the location of the true geographical South Pole has to be restaked every year, something like 20 or 30 feet, I can't remember, or maybe it's 20 meters. I have trouble remembering some of these things now. And the only flag at the geographic South Pole happens to be an American flag, because our tax dollars are paying for this whole operation at South Pole Station. But it's really something when you're flying into South Pole, because we have the freedom to step up forward to the pilot's cockpit. And if you might be up there as the tiny appearing station shows up on the horizon, you're looking down, the Transantarctic Mountains have long passed behind you, and there is nothing but what looks like a vast frozen ocean, flatter than Kansas, behind you, and you're looking down at the high Antarctic plateau. Finally, a tiny dot in the middle of nowhere appears. You descend towards it, that's South Pole Station, and you ski in on a maintained snow and ice runway. And well, that's what you're seeing going on there, but I better keep going or we'll never finish. You tumble, now at least back in 1994, because the nature of the base has changed tremendously since I lived there for a year. But when I was there, I tumbled out of the airplane with the others and headed immediately towards this gaping door down there. There's a sign, and I remember what it said: the United States of America welcomes you to Amundsen Scott South Pole Station. And you walk down there and you sort of gulp to yourself, because you think to yourself, holy mackerel, this is the front door of where I'm going to be living for basically a solid coming year. Because if you want to do something down there, if you have science duties of some sort, it is not humanly possible to leave South Pole Station once the winter over period begins. The relatively short, relatively warm Antarctic summer allows aircraft to fly in and out, something like 3 or 3.5 months. That's the only window. So I arrived a little bit after New Year, and but as the sun, which was up 24 hours a day, as it got closer and closer to the horizon, as the Earth turned, eventually it got too cold for airplanes to land again, and we were there stuck all on our own. And so that's what makes the winter over experience unusual. But anyway, I'm there in the extreme cold weather clothing. It's very sunny. The sun is warm on your skin. Won't be like that forever. But anyway, I better keep going to show you stuff, what it was like. Now, okay, inside the mighty geodesic dome, which is no longer there, I'm afraid, because they've changed the base. That dome was a wind and snow shield to protect us against blowing snow in the more severe situations. This is an extreme wide angle lens, obviously. It's actually a 9mm lens, Nikon 9mm lens, fisheye, and it is offering an entire 180-degree field of view. And the bright spot on the ceiling there is actually a ventilation area that is straight overhead as you're standing there in the middle of the dome. The dome obviously is not heated. It's, like I said, a break against wind and blowing snow. The red buildings, however, are heated. And as I'll be showing you a little bit about them, they are where we lived, where we ate. Some of the laboratory buildings were inside, the laboratory facilities were inside these buildings, inside the dome, but many of the experiments or observation facilities were outside the dome, as you will see. But one thing I want to point out, see those white doors there? Well, they kind of look like refrigerator doors, or maybe more specifically, meat locker doors. That's exactly what they were. They were relatively newly added. That was actually the dormitory facility there on the right-hand side. And it seemed like the administrators from National Science Foundation were kind of proud of the new meat locker doors on every dormitory room, tiny little rooms, as you'll see. But those were emergency escape hatches. Interestingly, wouldn't you think that if you were destined to winter over at South Pole as part of the United States Antarctic program, as we all were, that you would get some special training to avoid freezing to death? I didn't get any training like that. However, we all got rather specialized training on how to avoid burning to death and fighting fires, because fire danger is actually considered one of the most serious things. because the buildings were fundamentally wood framed. And if a fire starts, like an electrical fire, you don't have much in the way of water. So you have to depend on chemical fire extinguishers, and fires can be very, very serious. So they had various emergency escape facilities like these doors. Of course, if you're, lounging in your underwear in bed or something, a fire breaks out, you pop out the door into the environment under this dome where it's generally negative 50 degrees Fahrenheit. It's still quite an interesting situation, isn't it? But anyway, I better go on because I have so much to say. That bright ventilation at the very top of the dome looked like this, with a modest telephoto lens high overhead. Each of those holes was actually about 3 feet in diameter. Now, there's a fair bit of humidity, relatively speaking, inside the geodesic dome. It's aluminum. The humidity was coming from human activity, cooking, the exhaust from the big Caterpillar tractors that would be bringing supplies in and out. The relatively warm air would rise and go out through the ventilation holes there, the size of big manhole covers. However, the humidity, the water vapor in the air, some of the water molecules would come in contact with the aluminum structure and freeze and create those giant ice crystals. You can see, of course, beyond there's a flagpole and a rather tattered American flag. But this whole phenomenon of the relative water vapor in the air, and it relates to why we were there scientifically, because extremely cold air cannot easily hold much in the way of water vapor. But water vapor is what absorbs many wavelengths of light and related radiation, like near infrared radiation, say from that you can observe with an appropriate telescope, or even microwave radio waves, radiation. All these radiations are very interesting astronomically and astrophysically. So to go to a place on Earth where the sky, the air would be very transparent to such radiation because the water vapor was so low, well, that was desirable, and that was what was driving our presence and our enterprise there. But here, quite a different view. I have actually, to get this picture, again, with the ultra wide angle fisheye, I have climbed to the top of the dome. I'm lying on my belly, and I've got my camera looking down through one of those holes. And you can see that there are 3 buildings inside the dome, and there are 2 people there spread eagled on the snow to dramatize just about how I'd look if I slipped through the hole and fell down. It was surprisingly creepy being at the top of the dome and looking down like this. But anyway, just to show off that there were 3 buildings protected by the dome. The dome was about 160 feet in diameter, as I recall. And the dormitory facility with the 2nd story and a lot of those meat locker doors is on the lower right. The building at the top was mainly a dormitory, a galley, in other words, a kitchen and dining area with some recreational space upstairs, a room to watch videos. The building on the left was some laboratory space like meteorological offices, some administrative office space, and very importantly, a room devoted entirely to communications and some other laboratory facilities that it's hard to remember because it's been so long, but let's keep on going. Now this picture is inside the galley or the dining hall. Many of the terms used to describe the facilities were still nautical in flavor, like the galley on a ship. It's because originally the Navy Seabees, the Navy engineers, had a lot to do with the construction of South Pole facilities. So the nicknames for various places hung over from the naval era. This picture is a little out of chronology because we haven't begun the winter over yet as I proceed in this presentation. But this picture was actually taken during the middle of the winter when it was only our skeleton crew present. And as I recall, there were 27 of us wintering in 94. And in this picture, most people have kind of long hair, maybe kind of greasy hair. There's a certain informality which becomes very natural at South Pole Station in the middle of a winter over, but that's the way it was. This shows what was my dormitory room and the emergency escape hatch that I guess I've maybe spoken too much about. I've situated myself very high with my camera, a wide angle lens, in the doorway to the little cubicle, a real monk cell, wasn't it? That's all there was, but it was very comfortable. You might notice that was an interesting graffiti there on the wall above the bed. And I do have to point out that I was not responsible for that artistry. I was not guilty of that tag, but what I was guilty of, somebody else had done that, some previous winter over, and I spent the year living in this room without taking the time to paint it over. And I think I spent way too much time living there thinking what was going through the head of the person who left this here for me to look at. And I never painted it, left it for the next person. But it was very comfortable in many ways. Socially, we were generally young adults. Let's see, of the 27 people, I think there were about 7 ladies, 20 men. There were 1 or 2 married couples. There were 1 or 2 couples that got established in the course of the winter over experience. And some of us were married, but they're singly. That was my case. And so it was an interesting diversity of social situations. We all became very close, and I would say generally friends. I think socially our winter was a particularly harmonious one because the lady who was the manager of the situation that year, well, she just had a nice, easygoing personality, and she had some authority choosing the people on the team, and I think she chose very well, and most of us got along very well with the whole group, and that is very important. But I better keep going with the pictures here. So this is showing the inside edge of the dome at one point, and that fellow there, one thing I wanted to say, his youth reminds me that in many ways, wintering over there felt kind of like being back in school, like being back in college, but no longer being just a college kid, having a chance to live in a college dormitory again, but as a slightly more mature young adult. And it was really very nice. Socially, it was a fun and nice experience. And we really did bond with each other because we depended upon each other and sometimes in very critical ways just to survive this experience. Anyway, who is this guy? He was our winter over cook. And it was kind of funny. His name was Ed. And as we were getting to know him, he said, well, gee, as a matter of fact, I used to work at the CIA, he said. And we all looked at him a little quizzically until with a laugh, he explained, well, actually, the CIA is the Culinary Institute of America. That's where he had gone to chef school. Now, the interesting thing is that the National Science Foundation is well aware that in the course of winter over at South Pole, there are a lot of things, to give you a sense of cabin fever, to make you feel a little bit burned out or a bit depressed. before the winter over experience is done. They don't want food to be one of the things you're depressed about. So they tend to send down a very talented chef and very good food. And so what are all those boxes to the right and left of Ed? Food left over from previous winters. Ed calculated that if there were an atomic war or something, there would be enough food at South Pole Station left over from previous years that had gone uneaten, stuff like that. We could have kept eating what was already there for maybe about 7 years, because these boxes were all around the whole circumference of the 160-foot diameter dome. The problem was most of it was stuff like frozen okra. And there was a stack of that beside the dormitory staircase. I spent a lot of time looking at it all winter, but not eating any of it. Of course, the stuff we ate were the king crab legs and the steak, and all the good stuff would get used up pretty fast. Things like frozen okra would be left over. Anyway, Ed made that observation about it, the okra, etc., lasting 7 years. But of course, we would not have had enough diesel electric fuel to survive anywhere near that long if the world had come to an end around us and nobody had come to get us. But we would have enjoyed a little bit of okra in the meantime. Oh, by the way, behind him, there's a ladder. There's like a chimney-like emergency escape structure. You'll see it from the outside in a few minutes. So if something catastrophic happened inside the aluminum geodesic dome, like a big fire, you could go crawling up that ladder and then crawl down outside. And of course, you'd be there standing outdoors at South Pole Station, where the temperature without wind chill would not infrequently be below -100 Fahrenheit. So it was nice to have an emergency escape hatch, but what is it that we would be escaping to? Well, of course, there were other buildings one could go walking over to. That was the idea. I'll spend a little bit more time trying to describe the dome and its environment. Here, there was a tower near the dome, which was actually for sky observation, studies of the southern lights, ionospheric research. It was a relatively tall laboratory facility. So I'm at top of it looking down at the dome. But the thing I want to point out is that there's been a fair bit of excavation around the dome by using heavy machinery. See, the issue is if you build anything on the Antarctic plateau, there's a fairly steady wind stream, about 12 miles an hour, coming out of one particular direction, which happens to be high ground, ever so slightly high ground. It goes up to something like 12,000 feet altitude above sea level on the Antarctic plateau. The altitude here at South Pole Station, according to the sign at the geodesic South Pole Monument, the altitude was 9,301 feet. The wind was coming out of one direction because the air is colder at the higher ground, and it's rolling down the Antarctic plateau because it's colder and denser. Anyway, the steady, relatively gently blowing wind would carry ice crystals that would tend to bury any structure built on the ice. So the dome here has been excavated so the pressure of snow accumulating around it would not crush it. So every once in a while, they'd have to go to a lot of work digging it out, getting it ready for another season. And that was a problematic issue for South Pole engineering. And that's really one of the reasons the architecture there has changed so much since 1994, as I shall illustrate in a minute. But here's a giant Jamesway that was in fact nearly entirely buried. This had a special purpose, and let's see if I have, I'm hoping you can see my mouse. I'm moving my mouse around, but right here, there's something, that's actually a person lying down, heads towards us, and his arms are extended to the right and left. A guy has flopped down on his back, head towards us. This big thing here, like all the others, these are fuel. They're like giant water beds of diesel fuel. They're fuel bladders. And you can see they're gigantic. There's something like 25 feet or more on a side. How do they heat the place through the winter? This is how they do it. During the brief Antarctic summertime, when the airplanes can fly, as I recall, there's something like about 130 or 140 flights to South Pole from McMurdo Station. With each one of those flights, there's actually a surplus of aviation diesel on the airplane. They can download some of it. Where does it go? Into fuel bladders like these. One fuel bladder, 2, 3, 4, 5, 6, 7, 8, you know, they disappear in the distance of this gigantic metal structure. There's another person right here. I'm circling them with the mouse to give you a sense of the scale, and something like a sidewalk here in the snow. So these would be filled up like giant water beds during the summertime, but when the last plane goes, this aviation diesel would be used and pumped to a diesel electric generator that would generate the electricity. A lot of the heat was electric. It would last all winter long. The exhaust from the massive generator, and there were actually 3 of them, only one of them was running at one time. The other was an emergency backup, and the third one was getting like maintenance work done on it. So, but each one of them was gigantic in its own special room, but the hot exhaust from the mighty diesel electric generator had a glycol loop in the exhaust, which would get very hot. The glycol would be pumped around the station like hot water in a radiator, so the energy would be conserved. So it's very interesting. All the engineering for keeping the place running, well, actually had been very well perfected by the time I was there in '94. And it's all very interesting in its own right. But let me tell you what's going on here. See the cloud? That's actually a contrail. That is the contrail from the last plane leaving. And everybody on the station, of course, comes out to watch that plane leave. It's a fairly, well, by some measures, it's a somber moment. Now, I did something of a little nosy photographic study. I was running around with my camera. I took pictures of people of their faces. And we all bore rather serious expressions watching the last plane leave, because we're all thinking, well, what's it going to be like? We're really destined here. We're alone here. The winter over has begun. Or we're going to be able to sort of deal with it and handle it. Well, I tell you what we did. We all sort of walked in there like zombies back to the station. But it was really actually quite nice, because finally we were left alone. Everything was up to us now. And it became a party day. We broke out the beer and we got out the video, and we watched both versions of the notorious science fiction flick, The Thing. That's the one from the 1950s and the one from the 1970s. Then they're both, they involve Arctic and Antarctic monsters from outer space that awaken out of the ice, and the monsters eat everybody. And the later version, directed by John Carpenter, has got to be rated X for violence. And so it's absolutely the wonderful thing to do on the first day of winter over at South Pole Station. It was a wonderful party day. Okay. Let me show you pictures of some people sort of doing their thing. This is one of the 2 lady meteorologists, Anne, who was with us that year. She's beside a rather quaint instrument, almost a sundial-like instrument. It was like a crystal ball that would focus the light from the sun. And as cold as it was at South Pole, even during the bright daytime, this crystal sphere of glass would collect enough sunlight to burn a mark on an interchangeable strip of paper that had time graduated on it, so it would automatically record sunny hours. Kind of an old-fashioned meteorological instrument, but kind of cool. But because at a place like South Pole or North Pole, when the sun is up and as the Earth turns, the sun appears to move essentially parallel to your apparent horizon. By this time of year, the sun was getting a little bit lower, a little bit closer to the horizon with every passing day. Since it's going completely around, we needed two of these instruments to record the sunny hours automatically when the sun was behind us or when the sun was away from us. Anyway, that's just one of many, many things, including much more modern technologies that the meteorologists use to monitor the weather. But I love historical instruments, so I couldn't help but show it off. Here's a guy named Brent, and he was our principal communications engineer. It looks like a satellite TV dish, but a rather large one. He might have been shaking off some blowing snow and ice crystals. But this was particularly important, much more important than typical satellite TV. This was our principal internet link. Communications, at least back in '94, and I strongly doubt they have changed much since '94. Communications could not be taken for granted. We had access to one geosynchronous satellite, which appeared very low to our apparent horizon, given the nature of geosynchronous satellites. This dish had the satellite in its field of view, maybe 5 or 6 hours a day. The satellite was no longer terribly stable in its orbit. There was a bit of north-south drift. That's why we only got it a few hours, a handful of hours a day, and we could get the internet signal only in rather clear weather when there wasn't too much blowing snow. So interestingly, even things as basic as email were rather new at South Pole Station, at least for the general population back in '94. And to further dramatize how things have changed, the first time anybody ever demonstrated to me what a website was in '94 at South Pole Station. Our information technology officer, a friend, pulled me into his lab and said, "Hey, John, take a look at this. They call it a website, and I think it's going to be a big thing." And of course it was. But anyway, I better keep going. Okay. I explained before how anything you build at South Pole gets covered by wind-blown snow. What I must remember to mention is there's not actually much precipitation at South Pole Station. It may only amount to about 4 to 6 inches of additional snow per year, something like that. However, the wind-blown snow can really bury things. Again, it has to do with the wind coming out of generally one direction all the time. And so in this case, the wind was coming from left to right, and you see the aerodynamic effect around this curious structure. And my friend John, who is one of the science technicians. Now, John, who looks like the angel of death there, or some kind of cross between that and a scientific Santa Claus, he is about to go down this thing, kind of like a chimney. At the bottom of it is a seismograph in a small, warm hut. But there were a number of experiments like seismographs out around the base center that people like John had to maintain. And so, but the shack containing the seismograph would get entirely covered. So they build a chimney up to allow somebody to still access the scientific instrument. Now, the problem is sometimes they wouldn't get around to building the chimney up taller, even though the snow, windblown, had formed something of a mound around it. Here's another seismograph site, but in this case, John is having to dig down to the top of this so-called chimney. And here he has paused, and a couple things here to notice. he's exhaling through his nostrils, and he looks like some kind of dragon, doesn't he? Now, the thing is, with every exhalation, we all were engulfed in clouds of cold condensation like this. So generally, pictures of people outdoors, as a photographer, you would avoid these things. But here, I was letting them dramatize a little bit. He's got the cover open. We're going to go down there. I'm going to show you what it's like. But note behind him, there's a rope line, and there are bamboo poles, and there are flags, and they are going between this dead-end scientific station and the heart of the base. The idea was, if you go down to maintain a seismograph, it was always possible for a whiteout to come rolling in. In other words, wind-blown snow that would be so intense and overcast that you could not see anything, especially in the wintertime. So among the first tasks after the last plane left was for the station crew to put up all these rope lines, so that if we became disoriented working on something, we could come back up or come out, and at the very least, we could follow the rope back to the safety of the station center. Did I believe these ropes were necessary? They were comforting, but in my experience, I didn't find them really necessary, because believe it or not, you could hear the diesel electric generator and in the distance and follow it in. But anyway, let's keep going. Climbing down the chimney, inside the hut, it looked like this. Talk about a refrigerator that really needed defrosting. The next picture shows what it's looking like, how tall the chimney was. Look at the size of the ice crystals. Look at the light bulb there at the bottom. I'm looking straight up with the camera. And I found the ice crystals very beautiful for the sense of scale. I took my gloves off so you could see my fingertips to dramatize the size of these naturally forming ice crystals. It was -50 degrees in a below snow chamber like this all the time, constant temperature, -50, because -50 Fahrenheit is the average of the year-round temperature. Snow is a fabulous insulator, and you don't have to go down very deep into the snow before the snow is insulating and averaging out the year-round temperature. However, of course, it got much colder than that up above in the darkness. But if any tiny trace of humidity is in the air, and even though the air was always very dry everywhere, whatever residual humidity is in the air when one of those water molecules touches the walls of this structure and the ice crystals, it would freeze. And the crystals would grow bigger and bigger and just be very beautiful. But again, dramatizing the dryness of the air and why we were there. So another couple guys doing their job. These guys were part of NOAA, National Atmospheric and Oceanographic Administration, whatever it is. They were studying the ozone hole, among many other things. And they're inside the end of what was effectively like a garage building. They had a big door. They're preparing a weather balloon, but it's a very specialized weather balloon. It had an ozone sensor, and they're called an ozone sonde, a radio sonde, to sniff out the concentration of ozone in the upper atmosphere. But they had kind of an interesting task. This was among many they had many weekly activities and observations to make. But here's what it was like for this team of friends. They've carried the balloon outdoors. The guy on the right has the easy job. He's just going to let go of the balloon. The guy on the left has the hard job, because this is actually a gigantic balloon. As it goes up in the air, it inflates it expands to a gigantic size. The guy on the left is holding the very valuable sensor, so it doesn't go dragging along the ice. The wind is blowing 12 miles an hour from right to left. The guy on the right lets go of the balloon, up it goes, but the other fellow has to run along underneath it as it rises because he doesn't want that $3,000 instrument, and they only have so many of those to last all winter long. He's running along, and finally it's fully extended, and he can let go and catch his breath because, again, the geographic altitude is 9,300 feet, and at that point it would go up and up and up to 80 or 90,000 feet all the time, making measurements of the curious ozone concentration that they wanted to study, the so-called ozone hole, and radioing back down the concentration. By the way, notice the blue building on the lower right. That's a big building. You can't really tell, but notice there's a dish on top of it. That's that same communication dish that the engineer was standing beside before. Notice that building is up on stilts. That building exemplifies the new South Pole Station architecture. That building was brand new when I was down there. But let's keep going. So as time passed, slowly time passed, the sun got closer and closer to the horizon. Shadows got long. And these are shadows from one of our astronomy buildings up on stilts. We had a storm, so I did not get to see sunset. Storm came. I dearly hoped to see sunset because if it is clear at sunset, which is a long, lingering event, because the sun is changing only very slowly in altitude, it's appearing to go round and round, almost as though it's rolling along the horizon. But as the last top bit of the solar limb disappears behind the ice horizon on a clear sunset, that last bit of limb can be subjected to extreme atmospheric dispersion, resulting in something called the green flash. I can't go into it all now here, but to put it briefly, it is possible at South Pole Station to watch sunset once a year, or also sunrise, but sunset, whereby for the last few, the short period, final period before the sun disappears for the rest of the winter season, it's green. The top limb of the sun is, by dispersion in the Earth's atmosphere, is green, and the whole world is bathed in a brilliant emerald light. I've known people who've experienced it. It's the most profound green flash I think possible on Earth. It can last 45 minutes. It's an amazing thing, but I didn't get to see it. Why? Because sunset got clouded out. A few days later, when it cleared, at least we were rewarded with a beautiful big full moon. And this was one of our principal observatory buildings in '94. And that is one of my two colleagues wintering with me from Center for Astrophysical Research in Antarctica. But let me show you more. Okay. This briefly, this is the only graph I show. Horizontally, it's actually data from 1992, but this graph was posted on the wall of the meteorological office, and every year is very similar. This is the whole year from January, the first day of the year, January 1st, here to 361 is labeled there, but it's the whole year in '94, and this is temperature. It happens to be graphed in degrees C, but one thing to remember is -40 is the same whether you're talking Fahrenheit or centigrade or Celsius. And so when let's see, when the sun is high in the sky, the temperatures are around -25 C. The red line is a running average. The darker line is the actual day-to-day variation. Notice that the actual temperature changes very violently at South Pole. But what we're seeing here is the average temperature goes down and then it kind of flatlines, doesn't it? Because this is the date right here around March 21st or whatever, when the sun is set. as soon as the sun is set below the horizon, even though there might be a lot of lingering twilight because it's not far below the horizon, it gets cold. And any of these extreme cold moments here, although we're looking at a graph with degrees C, these would be points below negative 100 Fahrenheit. But notice how warm it can get. Man, when you're used to nearly negative 100 Fahrenheit and it goes up to like above negative 40, it's surprising how warm negative 40 feels. It's really true. What was causing this? A windstorm. The warm periods were windstorms blowing in relatively warm air off the ocean. When was it coldest? It was coldest when it was clear and the winds were relatively low, and there could be very strong, oh gosh, the cooling, the radiational cooling that meteorologists will talk about. That's when it got really cold. As soon as the sun appeared, this is 6 months, the sun is below the horizon. When the sun reappears, the temperature begins to creep up again. Okay, well, the sun was set. What's going on? The wind-blown snow is beginning to accumulate close around the door, but nobody is taking the time anymore to keep it dug out so much. There was one day in the lingering twilight, after the long lingering twilight after sunset, that it was below negative 100, and I thought today's a good day to go out and walk around and record what it just looks like. The interesting blue light, of course, everything about it looked really cold. And so I walked around the base, around the dome, and I recorded these pictures very intentionally when it was negative 100. Now, the clothing you're wearing is actually so good that you can spend a lot of time outdoors. Yeah, it's a little uncomfortable. It's cold, but you are surprisingly functional if you're determined enough. It's tricky with your hands. If you're trying to do something with your hands, well, that can be injurious. You have to be quite careful, but it's possible to function given the amazing clothing. So what is this thing with the red light? That's that emergency escape chimney that the cook Ed was down here at the bottom of. Look at how fast the snow has begun to blow in around the dome. Here, there's a ladder going up the outside of the dome. That's what I climbed to take that shot looking down in. But it was really something to walk around on a negative 100 day. But what was it like when the twilight is over? It's truly dark. We have gone beyond so-called astronomical twilight. It's taken a long time. The darkness doesn't just come on. It takes weeks and months for the sun to get low enough below the horizon for it to get really dark. So to go out the front door, the big doors are no longer being used, but there's something that's man-sized, and you go out. And we're just outside, it looks like this. The snow is blowing in, and you feel like you're on a crater on the moon, a little crater, but you've got to climb up and out of that crater to look around up at the sky and all that. So up and out I climbed. And that's kind of what it looked like outside. That's actually a gamma ray telescope, probably a few hundred feet away from the base door. But for those people listening who are familiar with the constellations, this gamma ray telescope was operated mainly by the University of Wisconsin, and we were friends with them, and we worked together on some issues related to it. But anyway, if you're familiar with the constellations, just look at the sky background. The stars are trailed a little bit because I had my camera on a tripod and left the shutter open, maybe, I don't know, 2, 3, 4 minutes to record this picture. The Earth is turning, so the stars appear to trail. That's Sirius, the brightest star in the sky. is part of the constellation Canis Major. But if you know the constellations, you recognize Canis Major here. These are like the feet of the dog, and that's at sort of the chest of the dog, the big dog, but it's upside down because, of course, from South Pole, everything in the sky appears upside down from what we're used to here. Now, interestingly, for constellation buffs, down here, there's a little bit of, there's something down here, and you might be able to imagine that I'm telling you something there from the sky is shining in through the structure of the telescope mounting with an ever so slight pink color. It is pink because it's the Orion Nebula. If astronomers among us here will remember that the belt of the constellation Orion is right near the celestial equator in the sky. The celestial equator is the same as the apparent horizon at South Pole, but all we ever see are the southern stars, the southerly declination, or like the southerly latitudes of the sky. The Great Orion Nebula is about 4.5, 5 degrees southerly declination. And if you walk outside and if you could just barely see the faint glow of this hydrogen gas cloud glowing pink in the sky, that would mean that there wasn't too much blowing snow, because if there was more, well, it would be above 5 degrees, wiping out any view of the hydrogen gas cloud so famous in the constellation of Orion. But anyway, it was really something, stepping outdoors and looking at such an alien environment as what South Pole offered. So almost every time, and probably every time one stepped outdoors, there would be a little bit of auroral activity in the sky. Charged particles erupting from the sun are caught by the Earth's magnetic field, and they get pulled in, and they tend to travel along magnetic force field lines and get concentrated near the North Pole and the south magnetic poles of the Earth. On this day, there was a great big auroral arch crossing the entire sky. This is actually a fairly wide angle lens looking essentially straight up, but I was taken by this phenomenon because the arch was sort of cutting our sky into two halves from horizon to horizon. And so I ran in, got my camera, and took this time exposure, and I kept it short because the aurora was bright. And I didn't want the aurora's motion. There was a little bit of motion. I didn't want it to get blurred out because of the apparent changing pattern of the glowing phenomenon high in the Earth's atmosphere as the particles from the sun collide with our upper atmosphere and energize a gas and make the glow. That's what the northern lights or the southern lights are. And that's a whole field of study in itself, of course. But suddenly things changed. Notice right here, I'm going to leave my mouse near that star, but things changed fast. Suddenly the aurora began to move much more after I ended the first shot. I'm going to leave my mouse there, move to the next slide, and the camera shifted a little bit, but that's the same star. We're not seeing as many stars because this was a shorter exposure, so I'm not recording the background stars so brightly because the aurora had begun to move pretty fast, and I didn't want its structure to get entirely blurred out from its own motion. And I was using film. This was before so many electronic cameras. And of course, electronic cameras don't work very well at these extreme cold temperatures. So I was prepared with film. And the most beautiful aurora that I saw while I was there was this display where it was raining down all around us in the sky. And you can see the silhouette of the big geodesic dome. You can see the flagpole, and you can see light coming up past those ice crystals where we were before when I was lying on my belly. You can see the exhaust from the diesel electric power plant getting illuminated by what was in effect a street light way over there. But the aurora, of course, could be quite beautiful. One of my duties was to climb this meteorological tower, which was quite tall. I had to climb it fairly regularly, but it was nice, had nice stairs, so it was not a big deal. But this is where this picture is looking towards the heart of our Milky Way galaxy. And this here is actually the constellation Sagittarius, the scorpion. But again, like before, it's entirely upside down relative to the horizon compared to how we're used to it. But let's see what's also over here, the teapot. Here's the teapot of Sagittarius right here, and the spout. And there's a big star cloud there that people think of as the steam coming out of the spout of the teapot-like pattern. And the scorpion has a tail. There are the stingers, the curved tail going down like this, the bright star Antares, and stars here that are representing the claws of the scorpion. Anyway, the cool, familiar constellations. But my favorite self-portrait of the whole year is me climbing this tower. Let me show you. Except I think first I'm going to show, oh, there I am. There I am. And so I had only been outdoors probably 3, maybe 4 minutes when I paused to take this picture, this selfie. The hand holding the camera at an arm's length with a wide angle lens. But I've opened my jacket to bring the camera out, because you got to keep the camera close to your body to keep it warm. I've taken off a glove to an inner flexible glove with dexterity. I've pulled my hood back, which I would normally never do. When you breathe, the humidity coming out of your body makes a cloud of relatively humid air around your face, even when your hood is up and everything. But your eyebrows and your eyelashes are very, very cold. That doesn't hurt, but they're cold enough so that the humidity in front of your face freezes out on all your little hairs, and it makes for a dramatic situation. You get used to it. It's a little uncomfortable, but you can deal with it. It's not really hurting you. If you take off the full face mask and leave it off for about 100 seconds, that's all it would take. If you expose your head to the night air, within about 100 seconds, you'd begin to feel frostbite on the more tender little folds of your ears. It was part of the fun. Oh yeah, I'll skip this. There were some microthermal sensors at the top of the tower that I had to maintain. Basically, we were measuring changes in air temperature that related to air turbulence, that related to how sharply can a telescope see set up looking through the mix of air temperatures at South Pole Station. That was one of my duties. Basically, taking measurements to understand how much the stars twinkle at South Pole. And there was actually a friend, a graduate student associated with us at an Australian university, who got a PhD thesis out of the data from the sensors covered over by these tin cans. And but that's another story in itself. One could attempt to use a small amateur telescope at South Pole, and I did, and I looked at things, but the optics would become heavily frosted because of relatively high water vapor that would blow through, and the instrument was especially cold. But we learned to wash the frost off using acetone. To make a long story short, I know I've got to keep going because the stories are just too long, but we could clean optics with things like acetone, which would not freeze in the very, very cold. We basically wash off the ice from optics with acetone. This was our main laboratory building for astronomy, but it was 1 kilometer away from the heart of the base. Nobody had ever operated during the winter so far from the dome. So it was considered sort of a big deal. How practical it would be. It was very practical. But let me show you some of the things out there. We had built a 24-inch diameter or 60-centimeter reflecting telescope. There was a mirror inside this short stubby tube, and collected light, and we had a special camera that would photograph things in the near infrared at a wavelength of about 2.4 microns, which one way to think of it is it was about 4 times more red in the spectrum than we can see with the human eye. And but it was particularly important to test the views with a near infrared telescope, because it was predicted that the Earth's air was so dry it would allow a very, very clear view. And we were able to confirm that. This is a fellow named Joe Spang, who he operated that gamma ray telescope from University of Wisconsin. But Joe assisted us during a particularly hectic time with this telescope, as I'll explain. The telescope was normally protected with like a baby buggy cover. It's folded down now. Those look like clouds in the daytime sky, right? A little cirrus. No, this is nighttime. The moon is out. It's illuminating things, but those so-called clouds are actually auroral displays. The picture is a little soft because my camera on a tripod was blowing in the wind. But the thing is, back in '94, there was a very, very famous and special celestial event which created worldwide news. Comet Shoemaker-Levy 9 had fragmented, and the many parts were colliding on schedule into the planet Jupiter. It was world news. Jupiter was at negative 16 degrees, which placed it in the southern sky 16 degrees above our horizon, and perpetually above our horizon during the week that the comet fragments crashed into Jupiter. We were there able to watch them all in infrared light. And so this is what Jupiter looked like. Well, maybe not a heck of a lot, but let me explain. Jupiter itself would be seen as a disk, but it does not glow very brightly at 2.4 microns at all because it's kind of cold. But two of the moons, Io and Ganymede, that were discovered by Galileo, they shine quite brightly in near infrared. Something, however, had been going on Jupiter before we started this particular sequence of exposures. It's labeled G. Thing is, the comet fragments had been given letter designations, and their impact time and date had been calculated ahead of time with a precision of plus or minus about 3 minutes by the Jet Propulsion Laboratory. So they came in and crashed into Jupiter over the course of about a week. We had to man this telescope very frequently and intensely over a course of a week. Joe helped us right on schedule. We were clicking pictures. We had to press a keyboard. The time was automatically recorded, but the software was still so primitive. This was the first year the telescope was operating. We had to press the button to take the picture, but right on schedule. Whoa, something is beginning to start. It's obviously happening. Fragment H has collided with Jupiter with the energy of like an atomic bomb, and a few exposures later, the energy is saturating our infrared detector. But then over time, many minutes, many hours, the heat from that impact dissipated back down again, and maybe 6 hours later, yet another fragment of the comet came in. So it was a very exciting time, and another graduate student got a PhD thesis based upon these data that we recorded at South Pole Station. And so that was gratifying, of course. This is Kerry Vigue, our winter rover electrician. Before he went outside to spend about 40 minutes. That's what he looked like in the middle of the winter. Clothes are getting a little ragged, a little dirty. This is what Kerry Vigue looked like 40 minutes later coming back inside. You might notice his camera down there. He's got wires hanging out of it. That's because his flash unit was attached to the top of the camera at one point, but the camera is plastic. Plastic gets very brittle when it's down about -100. You got to be very careful with your materials. Things get very brittle. I could go on at length about that. This here was a very special moment. Remember that building with the dish and the engineer beside the snowy dish? I'm on top of that building. I'm looking out over the ice. This here, the big glow, that's the moon. This is a very wide angle lens with my camera. The lights are on the snow. They are diesel, like basically diesel campfires. My recollection is, from what folks told me, is that these campfires had been set up about 300 feet apart from each other. So we're looking over a very vast distance here, really, some distance away. And in the sky, in the picture, you might see there's blinking red lights. Blink, blink, blink. My mouse is blink, 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 blink. What this is, the diesel fuel fires defined a drop zone. The Air Force in the middle of the winter had, well, traditionally, and I think they still do it, a midwinter air drop. They did it as an exercise. And it's a big day for us. In the middle of the winter, we get a chance to have spare parts, fresh vegetables, mail from loved ones, all that kind of stuff, gag gifts for the sake of morale. This was the airplane flying overhead with a big door open, and the guys on board the plane are pushing out big boxes, about 27 of them, on parachutes, trying to get them to land in the drop zone. The boxes would then be gathered up with a big tractor. Here's Ed again in the middle of the dome. The tractor would grab them with the help of people out on the ice, people like Kerry Vigu, finding them, then pushing the giant boxes into the scoop of a great big tractor. Amazing you could get a tractor to run at South Pole temperatures in the wintertime. The boxes would be deposited inside under the dome and opened up. The parachute stripped away. The contents disemboweled. Look at the emergency escape meat locker door in the background. Quickly, the contents carried indoors, because some of these things, we did not want these things to freeze. So speed was of the essence. The contents being carefully inventoried indoors, actually in the galley. All the tables and chairs had been stripped away. Some boxes got busted up pretty bad in the impact, but interestingly, just about everything important got through fine. However, one of the crates with the parachute was never found our year. But we survived okay. Maybe it was just a bunch of tomatoes or something. I don't know. So, okay, this fellow, his cheeks, this was the worst case of frostbite anybody got all year. And it was the fellow driving the tractor. He was the diesel equipment mechanic, and he didn't bother to put on his face mask as he jumped outside that tractor to help people push the big boxes into the scoop. And he did that a few too many times over the course of finding all the boxes. It might have taken 2 or 3 hours to find them all. I can't remember, but he overexposed himself a little bit, but his cheeks were fine in the long run. Anyway, we're going to just wrap it up. I've gone on so long. A few more pictures of what it was like in various light conditions. The Milky Way, the camera's vibrating a little bit, a long exposure. That's Sagittarius again. And that's Scorpius. This is Sagittarius. A little bit of aurora down there. Some things in distant storage on a berm, in profound frozen storage, but useful in the summertime. Back in our laboratory, there was a particular drama. My teammate, there were 3 of us from Kara. This young man was John Kovac, who had recently graduated from Princeton with an undergraduate degree in mathematics, but he was really something as an experimental physicist. This great big contraption before him there was basically a very elaborate thermometer, you might say, a bolometer technically. And it was the sensor to a radio telescope that focuses microwaves. And this instrument basically was measuring the intensity of the microwave radiation. So it's a radio telescope and really measuring the temperature of the microwaves. He's got the sensor looking down at the floor right here. See the dark circle? That is actually a tray of liquid nitrogen. He's using liquid nitrogen as a calibration source for this very sensitive thermometer. He's trying to make this thing work. In this shot, our other colleague, Hien, is with him testing it. John is smiling a little bit because this is already near the end of the winter, and there's been a great struggle. Nobody had ever wintered before an instrument as complex as this thing. And it was a collaboration with many universities, many instrumentalists, but it was John's responsibility to run it. it was finally beginning to work after a great deal of clever improvisation on his part. He's now a professor at Harvard University, by the way. The instrument was reassembled and carried outdoors into this structure. This was actually a radio telescope. The wooden structure is not the dish, but it's kind of a protective shield to keep unwanted signals away from the rather eccentric looking radio telescope inside. That thing inside was the radio telescope, and that's John Kovac down there, down on his hands and knees. He spent an amazing amount of time outdoors struggling with this complex instrument, making its pointing and tracking work and making the very complex bolometer sensor also work. But he was beginning to succeed. But by that time, the sun, I fear, was beginning to return. We were running out of winter. I'll now show quickly slides of the long, lingering twilight, because this is not like a regular sunrise. This is over weeks, maybe months. The sky was getting brighter because the sun, going round and round, was getting closer to our horizon. Our winter was ending. At one point, the moon and the planet Venus lined up like this. And for me, photographing it was kind of a Stanley Kubrick moment, man, being at South Pole and having the moon and Venus aligned like that. Unfortunately, sunrise got clouded out again. No amazing, rare green flash phenomenon for me. But when it finally cleared, the shadows were very, very long. And various activities to clean up the base. Somebody had a very powerful starter gun or something, or explosion, acoustically breaking loose ice crystals accumulated on the inside of the dome. Joe Spang getting a haircut. Everybody laughing, everybody in good spirits. It really was a friendly, wonderful bonding experience we all had. Notice the firefighting gear on the wall. Very important. Stuff like that was all over the place. You notice that the gal communications officer, she's wearing the very heavy boots, and Joe is wearing those big boots. It almost looks like some kind of joke picture, but it's not. We would acclimate so thoroughly to those big extreme cold weather boots. We would wear them all the time, essentially like slippers, day to day, inside or outside. This is not a joke photograph. It's just the way it was. We were completely acclimated to them, and it's amusing to me to look at it now, of course. A fellow named Thumper Porter, general maintenance mechanic, took the prize for the most impressive winter overpants. Finally, the first plane arrived. And again, we were all outdoors to watch this plane come in. It's a very emotional moment because on one hand, you're ready to get out of there. You've been toasty for a long time. That's jargon at South Pole for feeling burned out, cabin fever, but depressed. It's normal. Anyway, we're all outside. It's incredibly exciting. Janet Phillips had the privilege of, she was our manager, and she had the privilege of parking the first plane with a choreography of hand signals. Right there, by the way, there's a single American flag, a sign. That was the location of the geodetically measured real South Pole. Out here, that's where the telescope, that's where the astronomy buildings were in the distance. Anyway, the plane comes in. What a moment. There's loud, the smell, the fumes, everybody's there. Very, very dramatic. But with that signal there, symbolically, she is ending our winter over, because that is telling the pilot he's perfectly positioned. He can feather his props and let it. They never turn the engines off. But then the door opens. The people come tumbling out, and it's hugs and kisses all around. And the cycle of activity at South Pole Station begins again with the incoming new crew. Thank you very much for your attention and putting up with my long presentation. It's hard to show all these slides and not include some of the anecdotes. And I'll be very happy to hang out and answer any questions for those of you who survive after the long presentation.
Thank you so much, John. There is a question in the chat. What is the farthest South Star you can see from there?
Well, one way to answer that is that whereas the North Celestial Pole is marked in the sky approximately by the position of the relatively bright star Polaris, or otherwise known as the star Alpha of the constellation Ursa Minor. In the southern sky, unfortunately, there is not such a conveniently reasonably bright star near the South Celestial Pole. The nearest star to the South Celestial Pole in the sky has the designation Sigma Octantis. And so I guess you could say the farthest south star would be, well, at least that's visible to the naked eye, is probably Sigma Octantis. I'm not sure that's what they wanted to hear, but at least that's an answer for them.
Let me see. All right. Can I still?
I see one question. I'll just read it. It says, did you ever go back to the South Pole? Now, I did not. However, when I wintered over, it was actually the third, well, it was the final of what was for me 3 visits, because I got to go and spend at least a month there on each of the 2 previous Antarctic summers, developing some of our equipment and some of our experience. So I got to go all together 3 times. Would I have liked to have returned? Yes. Sometimes I dream about it. I dream that I'm back at the station. I think I have something of a recurring dream that once in a while that I'm back there and experiencing it again. And so I have fond memories, though the dreams can be a little freaky sometimes, I have to admit. I do know I have friends who have served in a winter over for several occasions. So people do it more than once. But let's see, how do they say it? The standard response was, the first time you do it, it's for the adventure. The second time you do it, it's for the money, because you don't have to pay taxes typically when you go there. But the third time you do it, it's because you're a nut. But actually, some people really enjoy it and have done it multiple times, though that's rather unusual. It takes a certain psychological talent, you might say, to endure the isolation. And I should inject, because there's so much to say, but I should not forget to point out that the social and psychological experience of wintering at South Pole is studied in some detail by psychiatrists, psychologists, sociologists, because it makes a very interesting model for what it will be like for people, say, serving on a lunar base or at some other very extreme remote situation. The Navy every year studies the South Pole crew because of how it relates to duty on board atomic submarines and things of that nature. But it's a very interesting analog for what serving at a lunar base very likely will be someday in the future.
there were a couple more questions, a lot of thank yous for a fascinating talk. And someone asked, do the structures change position?
That's actually a good question, because it turns out that it's rather challenging to anchor a really heavy structure with nothing more than the ice. The snow that's slowly accumulating. Remember, I said it only accumulates. The real precipitation is only something like 4 to 6 inches per year. Then, of course, they're measuring that somewhere out away from the dome or away from the current structures. But the snow eventually compresses itself and it turns into clear ice. You don't have to go down terribly far before it all transforms to clear ice. Then they've set up there are some very interesting physics experiments that are using the clear ice underneath the surface there as a great big particle detector, but that's beyond the scope of what I can talk about. But it's very hard to build something heavy that is anchored only on ice, because the ice with pressure, under pressure, tends to shift. So all the issues of building big telescopes, big structures, in a way that they will be stable, that ends up being quite challenging, because the things will slowly shift. And like I said before, the entire base is moving relative to the surface of the Earth, because everything you saw there is like the top of a gigantic glacier involving the entire Antarctic plateau.
This has been fascinating. And one of the people who's here was the winter over physician from 1981 to 1982. I don't know if you saw that.
No, I did not see that. And the funny thing is, that person and I would have been acquainted, because I was there 94, 93, and 92. So we overlapped in the summer of 92 before, maybe it was, I'd have to think, was that person, had that person just left before I arrived, or was that person incoming when I was there during it would have been sort of around January of 92 when I was there. So it's a small world when it comes to South Pole operations, but it's surprising how people can get involved in Antarctica if they really want to. If they're young and they have a trade, all trades, all manner of skills are necessary to keep places like McMurdo Base and South Pole Station running. And so it's a very, very interesting and wonderful place.
Walt said he loved this and he took a lot of notes, and he wants to know, what were your and Yerkes Observatory's main goals there?
We wanted to confirm that the near infrared sky was as fabulously clear as it had been anticipated to be. We did that. Observing the comet Shoemaker crash into Jupiter was not actually one of the defining goals, but it was a fabulous fringe benefit of our presence there with that relatively big infrared telescope in 94. A particularly important goal was to carry on the microwave radio observations that were, I didn't get into this, but the idea with the microwave radio telescope was to measure the cosmic background radiation, which is observable with microwave radio work, that has many very important cosmological implications. And the observations at South Pole, looking at details of the microwave background glow, which is left over from the Big Bang expansion of the origin of the universe, at least according to the theorists. The microwave radiation and details in it are believed to potentially have very profound clues to the realities of what the Big Bang was all about with the origin of our universe. Obviously, that's a lot to try to get into, when my goal here was to try to share the human adventure of what it's like in that environment. I have to admit, that's what I think most about, given my experience having been there. Just what a wonderful adventure it was.
Do you have time for one last question and a comment?
Oh, hell, I go on.
Yeah, thank you for spending so much time. So I just to clarify, John Roseberg, the physician, was there in 81 to 82, not 10 years before you. And he said his airdrop was the same day as the record low temperature.
Oh,
and
yeah, that's isn't that the way it works out? I did see a question there. Did people get along?
Yeah.
Did we have fist fights? Fortunately, no. I tried to allude to this before. Sometimes the social aspects do get complex and strained. Our year, I believe, was a particularly happy and harmonious year. It doesn't mean that everybody loved everybody else. Some people were more gregarious than others. Some people were a little bit more shy. Some people were a little bit more obnoxious. But in general, we had an unusually harmonious year, and I credit it to the wisdom of the lady Janet Phillips, who is the station manager, who was a very laid-back personality, wise lady from California, as I recall, who I think she just had a lot of insight, choosing people with pleasant personalities. So we had a happy time. We had a lot of parties, and I should emphasize more, we had a lot of laughs. And I'm afraid one of the very silliest people there the whole winter was me.
I think that's a good place. That's a good upbeat note to end on. And
Okay.
and I don't see any more questions. Thank you so much, John. That was absolutely fascinating. And the images are just breathtaking. So thank you for sharing your expertise with us. And thank you, Donna McCormick and Hampton's Observatory, for making this possible. We really appreciate it.
My pleasure, folks. We'll see you around. Stop by Magdalena. Stop by New Mexico sometime and we'll scope out.
Okay. Good night, everyone.
Bye.